Cryptography. Now, cryptography is what? It is the conversion of data into a scramble pad that is decrypted and sent across a private or public network. So, very simple. What is the cryptography? Cryptography is the conversion of data into the scramble pad code so that we can send it to the private network or public networks securely. This cryptography is used to protect the confidential data such as email messages, chat sessions, web transaction, personal data, corporate data, email, e-commerce applications. Objective for this cryptography is confidentiality, integrity, authentication, and non-repudiation. So this is the main objective for the cryptography, and this is the main thing to provide the proper security for the services and the applications. So it will provide the confidentiality, so nobody can see what we are doing. It will provide the integrity, that means the data will be the data which is it is intended to be the data. That means if it is saying that this is the text file, then it will be the text file, it is not doing anything else. Authentication it will provide. Then types of cryptography, we have different types of cryptography. First, symmetric and asymmetric. So cryptography is basically an encryption, and encryption, that means encrypting the data so that nobody can see and understand the data, nobody can understand the real data. So for encryption we have these two type of cryptography encryption. One is symmetric, other one is asymmetric encryption. Now symmetric and asymmetric encryption. Now symmetric encryption means it is using the secret key or shared key or private key that uses the same key for encryption as it does for decryption. That means when we use the same key for doing the encryption and for decryption the data, we use the same key. So it is called symmetric encryption using symmetric key. So it uses basically the secret key, shared secret, or we can say the private key also. Then asymmetric encryption. In this, it uses the public key, uses different encryption key for encryption and decryption, and these keys are known as public and private key. So it uses a different key for encrypting and uses a different key for decrypting the data, and it is called asymmetric encryption. So this is symmetric encryption and asymmetric encryption. Then there is one more type of that. It is called actually one-way bash. That is hashing. It is not encryption. It is called hashing. That is what one-way bash. Now the other thing is called the government access to keys, GAK. Now what is this? It is actually government access to keys. That means that the software companies will give copies of all keys, or at least enough of the key that the reminder could be cracked, to the government. So the government promises that they will hold on to the keys in a secure way and will only use them when a court issues a warrant to do so. And to the government, this issue is similar to the ability to wiretap the phones. So this is also the ability of, like the wiretapping, it is also decrypting the data. So government also have the key. So whatever the cryptography technology the companies use, so the software companies do what, they give the key to the government, and only in case of emergency the government can do what, can crack those on encryption also. So always remember the government has a key, so they can crack this. Now cryptographic keys are like this. Like we can say it as item C, D, and E. Items to which the GA, this government access to key, has no right to of access, like this, and the item to which GK, the government access to key, has right to access, like item A, B. Like now whole the whole key is not there with the government, but enough of it that they can encrypt or decrypt the other part. Now these are the encryption algorithms we have. We can say ciphers. Ciphers are the algorithm used to encrypt or decrypt the data. So we have different ciphers. Ciphers are the method, or we can say it is mathematical method of encrypting and decrypting the data. So these are the modern ciphers we have. We have classical, modern. So in a classical, we have substitution ciphers. Substitution ciphers, that a block of plain text is replaced with the cipher text. We have transposition cipher. The letter of the plain text are shifted about to form the cryptogram. Then we have modern ciphers based on the type of key used. That is what the public key or private key. That is a symmetric key or asymmetric key. So we have a block cipher. We have a stream cipher. So we have these different type of cipher. So, the private key cipher, it is same key is used for encryption and decryption. In public key infrastructure, where we use two different keys are used for encryption and decryption, and based on that type of input data, it can do the block cipher that encrypts the block of data of fixed size. That means it encrypt the size of the data, a block of the size of the block encrypt one time, and the stream cipher encrypts the continuous stream of data. So when the continuous data is going on, so it uses the encryption, it calls the stream cipher, and block cipher do used to encrypt the block of data. Now we have these algorithms, different algorithms. First, data encryption standard, that is called DES. This data encryption standard is an algorithm is designed. It is designed to encipher and decipher blocks of data consisting of 64-bit under control of our 56-bit key. Now DES is the archetypal block cipher, an algorithm that takes a fixed length string of text, plain text bits, and transform it into a cipher text bit string of the same length. Now, due to the inherent weakness of DES, with today's technology, some organizations repeat the process three times, and it is called 3-DES, or we can say triple DES, for added strength until they can afford to update their equipment to AES, that is Advanced Encryption System. So, Advanced Encryption Standard capabilities. So basically, this was the first encryption cipher we have, that is DES. It do use the 64-bit key, 64-bit encryption with the 56-bit key, and it is used to encrypt the block of data. But nowadays we required lots of different things, and it is not fulfill those things. So what the it is actually weak. It is actually crackable. So what the organizations do, instead of using the DES, they use triple DES. Now triple DES is not anything else. It is actually the DES three time they encrypt the same data with the DES, and it is called triple DES. But the advanced option we have is AES, that is Advanced Encryption System. So in place of DES, people use this Advanced Encryption Standard. This AES is a symmetric key algorithm for securing sensitive but unclassified material by US government agencies. So it used by the US government agencies right now, and this AES is an inter iterated block cipher which works by repeating the same operation multiple times, and it has a 128-bit block size with key size of 128, 192, and 256 bit respectively for AES 128, AES 192, and AES 256 bit. Now remember, as a bit goes increase, it increases the probabilities. So if suppose if you encrypt one password or one word with the 128-bit encryption, so that means chances of that encrypted value to get the real value from that encrypted value, the chances will be 2 raised to 128. That means there are possibilities of those hashes, those encrypted value, to be decrypted with the right value is 2 raised to 128. So remember, it is very large number. So as the bit increases, the possibility of decrypting the password by the hacker will decrease, because it get lots of probability. Now this is the AES pseudocode. Pseudocode, that means how it do the thing. It repeat the value every time. it repeat the iterated block cipher. It repeat what multiple times the same operation. So as you can see here in the code, it is doing this. This is just a pseudocode for the AES. Then we have RC4, RC5 and RC6 algorithm. Now this RC4, RC5 and RC6, these do what? For example, RC4, it is what a variable key size stream cipher with byte oriented operations, and is based on the use of random permutation. So it do use these RC4, 5, 6. It is for the stream of data, encryption of stream of data. So it is what the key size is stream cipher. Now RC5, it is a prematerialized algorithm with a variable block size, a variable key size and a variable number of rounds. The key size is 128-bit. Then RC6 is a symmetric key block cipher derived from RC5 with two additional features. It uses the integer multiplication and uses 4-bit working registers. That is RC5 uses 2-bit registers. So just like this is the algorithm snapshot here, you can see it uses like this. Then we have DSA and related signature scheme. Now DSA means digital signature algorithm, and DS, that is digital signature. Now DSA is FIPS 186 two specific and digital signature algorithm, that is DSA. Now that may be used in generation and verification of digital signature for sensitive unclassified applications. And digital signature is computed using a set of rules, that is the DSA. So DSA defines the set of rules, this is the algorithm, and by using this DSA we create the digital signature. And digital signature is a computed using set of rules, that is DSA, and a set of parameters such as that the identity of the signatory and integrity of the data can be verified. So it uses to manage the integrity of the data. That means if suppose, mostly like suppose we use the mail. So when we send the mail, so we put the signature on it. So when we put the signature on it, that means I cannot deny that this mail is not sent from me. It is me who is sending the mail. And if the mail is from if the other user get the mail, then it will be sure that the signature, that mail is sent from me, because it will match the signature of my personal signature with that it has the signature. Now it is actually doing this by the digital signature algorithm. So it uses the same algorithm to verify my signature. So it each entity create a public key and corresponding private key. So it uses a symmetric key. So when I sign the digital signature, I use my own key, and the other person will use their own key to check my signature and verify my signature. So private key I use to sign the document, and the public key will be used to check the document or verify the signature. So it select this is like a different this is a method of doing this. It is a pseudo code like select the prime number q such as that this 2 raised to 59, then choose t so that 0 is not greater than or equal to t and less than 8, then select a prime number p such that this with the additional property that q divides, and select the generator A of a unique cyclic group of order q and z. To compute A, select an element G in Z, and compute G P minus 1 and Q mod P. If A is equal to 1, perform step 5 again with the different G, and select a random A such that this, and then compute the Y is equal to A raised to A mod P. Now this is actually a simple way of doing this algorithm, this digital signature algorithm DSA. Then we have the other algorithm. It is called RSA, Rivest, Shamir, Adleman. This is actually three persons who created this algorithm: Rivest, Shamir, and Adleman. This RSA is an internet encryption and authentication system that uses an algorithm developed by this Ron Rivest, Adi Shamir, and Leonard Adleman. So that is why it is named as RSA. Then encryption is widely used and is one of the de facto encryption standard, and it is uses modular arithmetic and elementary number theories to perform the computation using two large prime numbers. And remember, these all algorithms are depending on the math. So it is a mathematical formulas used to create these values. For example, the RSA signature scheme. So this is the RSA signature scheme, and you can see the scheme is completely mathematical. It is the algorithm key generation for the RSA signature scheme. Then this is algorithm to see key generation and verification. So this is the key generation, and this is the verification method. And this is the example of the RSA algorithm. And we can see that it is actually a mathematical formula. Then we have message digest. That is one-way hash function. One-way hash function, that means we can one time encrypt it, or we one time we do the cipher and then we cannot reverse it. It is only one-way bash. So what we do here, we use the document, we use the message digest function, and then we generate with the hash value. Now we cannot go back. It is only one way. So these hash functions calculate a unique fixed size bit string representation called a message digest of any arbitrary block of information. And if any given bit of the function input is changed, every output bit has a 50% chance of changing. And if suppose the document which we are using with the message digest function, if any one of the bit is changed from here in the document side, then the complete 50% of the chances of that hash will be changed. It is only from one bit, and it is computationally infeasible to have two files with the same message digest value. And that means what? It is very much impossible that two files will have the same digest value. Now, note that these message digests are also called one-way bash function because they cannot reverse. So they cannot reverse, it is because they call one-way hash and one-way bash. So message digest function, we have MD5. We have MD5 algorithm. This algorithm takes a message of arbitrary length as input and output a 128-bit fingerprint or message digest of the input. This MD5 is not collision resistant, so use of latest algorithms such as SHA-2 and SHA-3 is recommended. Now, because it is an old one, so it is not a collision digest. So it do have the collision problem. So for that, we have the new version of it. New version of message digest function. We have SHA, that is secure hashing algorithm version 2 and 3. Now MD5 hash is a 32-bit digest digit hexadecimal number. Then is still developed. It is still deployed for digital signature applications, file integrity checking, and storing the password. But still, it is used to do these all things, to store the passwords, to store the check the integrity of the files and all. Then we have secure hashing algorithm, that is SHA. It is an algorithm for generating cryptographically secure one-way hash, published by the National Institute of Standard and Technology as a US Federal Information Processing Standard. We have SHA-1. It produces 160-bit digest from a message with a maximum length of 256 minus 264 minus 1 bit and resemble the MD5 algorithm. It looks and it resembles the MD5 algorithm. Then SHA-2, it is a family of two similar hash functions with a different block size, namely SHA-256 bit that uses 32-bit words and SHA 512 that uses 64-bit words. Then SSH3 uses the sponge construction in which message blocks are XORed into the initial bits of the state. Now, which is then invertibly permuted. So it do what it use the blocks are it use the block to use these XORed method, and then it will do the initial bit state, and it is invertibly permuted. So we have these SHA 1, 2, and 3 hashing algorithms. Then we have SSH. Now, what is SSH? SSH is basically secure shell, and this SSH is a secure replacement for Telnet and the BlackBerry remote utilities like Berkeley remote utilities like RLogin, RSH, RCP, and RDist. These are also remote login things, and these are remote utilities to manage the machine remotely, just like the Telnet. But these are not secure when we use this. For example, Telnet. So whatever the data we send through this connection, it will not secure. It is sent as a clear text. So SSH is a secure replacement for these type of utilities. So SSH provides the secure connection. It provides the encrypted channel for remote login, command execution, and file transfer also. And it provides a strong host-to-host and user authentication and secure communication over an insecure internet also. And how it will do this? It will create the secure tunnel from source to destination, that is from client to server. So what it do here, it creates the secure tunnel. That means in from one side it sends the data by doing the encryption, and the other side it will decrypt the data to C. Now in between, if the data is on the internet, if anyone try to get the data, if try to sniff the data, they will not get anything. Now SSH2 is more secure and efficient and portable version of SSH that includes the SFTP and SSH2 tunnel FTP. That means now we have the SSH2 also, which also include the SFTP. Now SFTP is actually use this utility to connect the FTP server securely, because the FTP server is not secure by default. That means if we do the communication on FTP server, so it is in a plain text and anyone can see the connection and anyone can see the data whatever we are sending. We are using username and password, and it goes through the wire and anyone can see that. Now instead of that plain FTP, what we can use SFTP, secure FTP by the SSH protocol, SSH2. This SSH2, it comes with the suite of protocols, suite of tools actually. So when we install the OpenSSH toolset, so in that toolset we get this SFTP also. And this SFTP use what? It uses the tunneling technology to connect the FTP server. So the same SSH tunnel will be used to do the FTP connection. So it tunnel the FTP to into the SSH tunnel, and it will send the data to the FTP server with the secure connection. Then we have Diffie-Hellman. Now Diffie-Hellman, this is the system. The system has two parameters called P and G. Now this is basically first a cryptographic protocol that allows two parties to establish a shared key over an insecure channel, then developed and published by Whitefield Diffie and Martin Hellman in 1976. So it is developed and published by these two persons, and this actually was independently developed a few years earlier by Malcolm J. Williamson of the British Intelligence Services, but it was classified. It was classified, but it was developed publicly and published by this Whitefield Diffie and Martin Hellman in 1976. So what it do actually, it's a cryptographic protocol that allows two parties to establish a shared key over an insecure channel. So if the channel is not secure like it is on internet, so what they do, we can use this Diffie-Hellman to create the secure channel, to establish the shared key. Now it is too much, it is having a lots of encryption, it is actually a very computational thing. So normally it is not used for the real time connection. It is used to actually, basically nowadays it is used to send the public key over the internet to the other machine. So basically, we use this Diffie-Hellman algorithm to share the public key to the other machine, and then that public key will be used to do the securing the communication in a asymmetric encryption, where we have two keys, public and private. Now these are the tool we have for doing the hashing. So we have MD5 hash calculators. These are uh, HashCal, MD5 calculator, HashMyFile. So these are the different tool we have to do the calculation of MD5 hash, or different hashing algorithm also, like this HashCal do calculate all the other type of hash also. Then we have the cryptography tool for mobile also, like MD5 hash calculator. We have hash droid and hash calculator. These are for mobile devices we have. Then we have some advanced cryptography tools, that is advanced encryption package of 2014. In this advanced encryption package of 2014, file encryption software, it supports the symmetric and asymmetric encryption both. So with using this, we can do encrypt the multiple files. We can encrypt the files and protect the file with the key. Now key will be the password for you. So when you put the password, then you can see the file. If you don't put the password, you can't see the file. Then other tool we have BCTextEncoder. This encrypts the confidential text in your message, and it uses a strong and approved systematic and public key algorithm for data encryption, and it uses public key encryption method as well as password based encryption also. Then we have these other cryptography tools also, like this Xcrypt, Stegnolocknot, we have AutoCrypt, we have Crypt, we have WinAES, Encrypt one click. Now we have by default on Windows, we have BitLocker, which do also encryption on the system, the drives. Then also we have the file encryption system on Windows. They do also the encryption of the files with using the shared key, or we can say the symmetric key. Remember, when we use the BitLocker, so what we do actually, we lock with the symmetric key, that is the password. And when we use the same password, then we can open it. And if we don't use the same password, you will not open. So it uses the same symmetric key. It is actually shared key, or we can say the public or private key, we can say. Then we have cryptography tools for mobiles also, like secret space encryptor, CryptoSymm, and Cipher sender also. These tools will do use to encrypt our data. Now, public key infrastructure, it is called PKI. This public key infrastructure is a set of hardware, software, people, policy, and procedure required to create, manage, distribute, use, store, and revoke the digital certificates. And this digital certificate used to manage the integrity, authentication, and it is used to do the security encryption of your data. So this component, the component for these PKI, that is public key infrastructure, first is the certificate management system that generates, distributes, and stores and verify the certificates. Then the digital certificates, that is establishes the credentials of a person when doing online transaction. Then validation authority, that stores the certificates with their public keys. Then the certificate authority that issues and verify the digital certificates, and the end user that requests the certificate, manage and uses the certificate. Then the registration authority, that this act as the verifier for the certificate authority. Now these are the component of the PKI infrastructure, the whole infrastructure. Now what is the infrastructure and how it works? So very simple. When you, the user, first try to connect some site. So first, suppose the user try to use some site. It wants to access some site. Like for example, you want to go to some online shopping site. So what you need, the site do what first? first the site will do what? They will secure their server, they will secure their site by this PKI infrastructure. So first they secure their environment, their servers, by using the PKI infrastructure. So for that, what they do, they go to the public certificate authority services and they ask for the certificate for their site or for their servers. So for that, actually we have to pay the amount of money for the subscription, and they will do what? They will provide you the certification services. So what they do actually, they verify your site, they verified your server by providing the certificate. By providing the certificate, and actually with the certificate they give you the private key also. That private key will be used to secure the communication from server and your server and the users. So first the server will do what? The organization will do. They use the certification authority services to secure their server. Now after doing that, the server, the site will be secured. Now when some user wants to connect the site, wants to get the server, then what they do? They first have to send the apply. They have to user have to apply for the issuing certificate to the registration authority. Now this whole infrastructure is made by the certification authority services, and that is, it is called the PKI infrastructure, that is public key infrastructure. So they have set these infrastructure where they have the RA, the registration authority, they have the authority, certificate authority, they have the validation authority. So they have these different authority servers on the internet, and they provide you the certification services. So when any user wants to access the site, so either they connect the site and the site says that I need the certificate and you have to go to this registration authority to get the proper certificate, or by nowadays our browsers are smart, and it has a database of the validate sites, like the famous sites we have, and it has an information about which certificate it needs. So we don't have to connect to the server to ask for the certificate. It will go directly to the registration authority, and it says that I want to get to this site, and for that I need a certificate. So this verification of applicant is done on this registration authority, and then it will do what? It will send the request for issuing the certificate to the certificate authority server. Now this certification authority server will do what? It will send the certificate to the user, and you will get the certificate to access this site. Now remember, with that certificate you will get the public key also. So you get the public key here, and the private key is actually there on the server, which is also given by the same certification authority services. So now you got the public key, and then what? When you get this public key, your information will be updated on the validation authority server also. Now your information, that means your certificate, that means this certificate is given to this particular user, that means your IP address will be there, and also the time of your machine will be there, like which time the certificate is given to this user, and then how long the certificate is going to be valid. So every information of that sub certificate and the key information, the public key information, is also sent here, and the information is also updated on this validation authority server. Now when you pass this certificate for the site or for this server, so this server will do what? It will validate that certificate with this validation authority, and that it will use the validation of the electronic signature, and it inquires about public key certificate validity to validation authority. So it validate the signature here. So the message, it is actually sending the message with the digital signature and copy of the public key certificate. So it is actually sending the copy of the certificate to the server when you send the request, and also it will send the digital signature which is given by the certification authority server. And then this server, the website server, will do what? It will try to verify the certificate from the validation authority. Now remember, the information of your is already updated there on the server, on this validation authority. So when the user, when this retail site, when they ask for the certificate, when they send the certificate to this validation authority for the validation, then it will say, okay, this user is validated, And if you have not getting this certificate from them, or if you are trying to use your own certificate, like you are the hacker and you try to modify the certificate, so your signature will mismatch. And if you try to create your own certificate, then also it will not be validated. So in both cases you will not be able to access that particular site. So if you are validated, then what, it will determine the result to the site, and then that site will decide that okay, you are going to access or not. Now if the validation is failed, then you will not get the access. You will get the error of certification expiry or certification needed error. And if you are validated, then you can get the access of the site, and then you will see the secure connection, you will see HTTPS. Now this is the whole public key infrastructure and how it works. And these are the certification authorities. We have online certification authorities, they provide the certification services. Like we have Komodo, we have Tot, we have Symantec, we have there are lots of many in Trust. We have Versign, we have Google itself providing its own certificate for its own services. Amazon, we have different services, certification authorities which provide the certificates. And our browser, when you go to our browser, you will see those certificates, root servers, you will see the information about the root servers and different certification authorities information also. So like we have gone to Google site. Now we can see this lock here. It is actually because this site is secured by the PKI infrastructure. When I click on that lock, I can see the certificate here which is valid. So when I click on this, I can see the certificate here, and it is issued to this google.com. So it is given to this particular domain, particular site, the issued by GTSCA, that is certification authority, and it is valid from this time to this time. It is actually valid for for some uh, okay, 2 months. And this is the detail about the certificate, that what it is intended for, what it is doing, what is it for. And then this is the part, and here you can see who is the certification authority. So it is GTSCA 1C3 which is giving the certificate to google.com, and it is taking the certificate from this GTS root 1. Then this GTS root 1 is taking the certificate from global signed root certification authority. So this is the whole path we have. So this is the certification authorities who is providing the certification to this domain, and when we access the domain or access the site, it gets the certificate from these, and then it is validated from this. Now our browsers knows about the certificates, like well-known certificates. If I go to the security, if I go to the settings, and I'll go to privacy and security. So here, where is it? So under this private privacy and security, we have security, and under the security, you have option to manage the certificates. And here, if you see this, there is a certificate here for me. Then these are the for other people, intermediate certification. These are the certification authorities. You can see Alpha, DigiCert, GeoTrust, Global Sign. We have GoDaddy, we have Microsoft, we have Cetigo, we have these different authorities. These are intermediate, these are not root, and these are the trusted root certificates. These are the trusted root certificate like Komodo, we have copyright, DigiCert, GoDaddy, Global Sign. So we have these different certification authority, root certification authority. So our server, our browsers knows about these certification authorities. So that when we get the certificate from these authorities, so it is verified and it is not giving any error about it. Otherwise, if suppose our browser or our machine don't know about the root certificate that means the authority which is giving the certificate. Like if suppose our browser does not understand or know this root certification authority, then it will give the error here. It will show me not secure or not sure about it. It says that this certificate I don't know who is sending this and I don't know about it. So because the root CA is not verified. So in that case, it will show error here. It will show cross sign here. It will say that site is not secure. You will use it in your own risk. Now, when it is happening, when we use the self-signed certificate. Now, what is the signed certificate and self-signed certificate? Very simple. The signed certificate, that means the user approaches a trustworthy certification authority and purchases the digital certificate. Remember, we have to purchase those certificates from these certification authorities. These certification authorities will not give you a certificate normally. You have to free, you have to purchase it. Because it is not just a certificate, it is the whole service they are giving you. It is the whole service they are giving you for securing your environment, for securing your web servers. So the signed certificate means it is the approach of the users which is getting the certificate from the trustworthy certification authority and which is purchasing it. And user gets the public key from the CA and he signs the document using it. And the signed document is delivered to the receiver and the receiver can verify the certificate by inquiring it in the validation authority. And validation authority verifies the certificate to the receiver, but it does not share the private key. But the self-signed certificate, now self-signed certificate, that means user creates the public and private key using a tool such as Adobe Reader, Java's key tool, Apple's keychain, etc., and it creates its own certificate to secure its own services. Then user uses the public key to sign the document and self-signed document is delivered to the receiver. And the receiver requests the user for his private key and user shares the private key with the receiver. Now here the key is shared. The key, private key and public key is shared with the sender and the receiver itself. And now they are not validating those things from the third parties, from these certification authorities. So here it is not secure because anyone who gets the key, because the key is stored into the same server. So if the key is compromised, if the key is compromised by the attacker, then it can decrypt all the communication of that user or that server. But the signed certificates which we use from the certification authorities, so the main key, the private key will remain, the master key will remain on the certification authority server. It will not give that key to anyone. So if attacker wants to encrypt the decrypt it by using the keys is not present here, it is on the certification authority. So you can't do this, you can't crack that one easily, but self-signed certificate can be cracked easily. Then what is the digital signature? Digital signatures are used for encrypting the emails and making sure that the email is signed by the user who's sending the mail so that the integrity of the mail will be intact. This digital signature used the asymmetric cryptography to simulate the security properties of a signature in digital rather than written form. So rather than written, like we write the signature at the end of the letter. So rather than lighting the signature, putting the signature written there, it put the digital signature on it. And a digital signature may be further protected by encrypting the signed email for confidentiality. So it will also be used to protect the email also. So what we'll do here, first the confidential information will be hashed and signed, and then it will be sent to the other person. Now remember, it is going to be hash and then signed with the key, with the digital signature. So it will be sent to the mail through the other user. It will be delivered from the server. Then the other side, the receiver, the server will accept the mail, and then it will deliver to the user. It will open here. Recipient decrypts one-time symmetric key using its private key. So the sign is done by the public key here, and it is decrypting by the private key. That is what. Then it will decrypt the message using one-time symmetric key, the symmetric key, and then unlock the hashes value using the sender's public key, and then it will get the message here. Then we have SSL. SSL is actually the secure socket layer, and this is also used to do the encryption of email. So this SSL is an application layer protocol developed by Netscape for managing the security of a message transmission on the internet, and it uses RSA asymmetric public key encryption to encrypt data transferred over SSL connection. So in this, what happened, this is the server and this is the client. So the client will do what? First, client send the hello message, that is including the SSL version, randomly generated data, encryption algorithm, session ID, key exchange algorithm, compression algorithm, and MAC algorithm. It send it to the server. Now server do what? It determines the SSL version and encryption algorithm to be used for the communication, and send server hello message with the session ID and certificate message, local certificate. So it actually send the user sends the this user sends the information about the version of its own SSL version. It sends the information about the other information like other encryption algorithms, what it can support, and then the server sends that what it can support, and then the server sends a server hello done message. Now when the hello done is done, then when the user verifies the digital certificate and generates a random premature pre-master secret that is encrypted with the server's public key, the public key which is given by the server, and sends client key exchange message with the pre-master secret. Then the server, the user sends a change cipher spec message and also sends a finish message, that is a handshake message, that is the handshake is finished. Then the server sends the hash value is calculated for the exchange handshake message and then compared to the hash value received from the client. If the two matches, the key and cipher suit negotiation succeed, then sends the challenge cipher fake message and also sends finish message hash of handshake message. So it do what? It do the challenge to the server, and server challenges the client saying that encrypt the message with this key, and if we try to decrypt it here, and if it is decrypted here successfully, that means it is using the right key to encrypt it. And this is, and the way they do authenticate their self, like they do authenticate each other, and they create the session. Then we have transport layer security. It is called TLS is also a protocol, and to establish a secure connection between a client and server, and ensure privacy and integrity of information during the transmission. Now it uses the RSA algorithm with 100 and 1024 and 2048 bit strength. It uses the TLS handshake protocol and TLS record protocol. TLS handshake protocol, it allows the client and server to authenticate each other and select the encryption algorithm and exchange the symmetric key prior to the data exchange. And TLS record protocol, it provides secured connection with an encryption method such as data encryption standard DES. So first they do create the session by doing the handshake. So like here client is saying hello, the server says hello server, server says hello, and with the server certificate, with the server exchange key, certificate request, server hello done. Now the client certificate, client key exchange, verification, verify the challenge cipher spec, and client finish message sent to the server. Now server changes the cipher spec, server finish the message, and then handshake protocol is done. Then the record protocol comes and they do what? They send the application data to each other. Then we have cryptography toolkit, that is also OpenSSL. The cryptography toolkit, it is called OpenSSL. Now OpenSSL is an open source cryptography toolkit implementing the secure socket layer, that is SSL version 2 and 3, and transport layer security, that is TLS version 1, network protocol and related cryptography standards required by them. The OpenSSL program is a command line tool for using the various cryptography functions of OpenSSL's crypto library from the shell. So this OpenSSL toolkit is used to do uh, creation and management of private keys, public keys and parameters, public key cryptographic operations, creation of X.509 certificates, CSRs and CRLs, and calculation of message digest, encryption and decryption with Cipher, SSL TLS client and server test, handling of SMIM, signed or encrypted mail, timestamp request and generation and verification also. Then the other toolkit is what the Keyczar. This Keyczar is an open source cryptographic toolkit and it is designed to make it easier and safer for developers to use cryptography in their applications. It supports the authentication and encryption with both symmetric and asymmetric keys. Features of this is the key rotation and versioning, safe default algorithm modes and key lengths, automated generation of initialization vectors and ciphertext signatures, Java, Python, and C++ implementations, and international support in Java. Then we have PGP. PGP is actually pretty good privacy. It is called pretty good privacy. Pretty good privacy is a protocol used to encrypt and decrypt data that provides authentication and cryptographic privacy. PGP is often used for data compression, digital signing, encryption, and decryption of message, emails, files, directories, and to enhance privacy of email communication. PGP combines the best features of both conventional and public key cryptography and is therefore known as hybrid crypto system. So how it do this? For encryption, PGP, what it do, it uses the data and then that data will be used to encrypt the data by using the random key. Now key will be generated, the key generate the random key first, then random key will be encrypted using the receiver public key RSA, and then what that key will be used to encrypt the data, and then the encrypted data will be added into the encrypted key. Like this is the encrypted data and this is the encrypted key, and both will be used to encrypt the message. So it uses this PGP encryption. This is uses the method to do what? Encrypt the message. Then for decrypting the message, it will do what? First, the data will be generated here, the random key. First, it generated the random key, and the data is here. The data is here. So it generated the random key. Now key will be generated by the encrypted key and decrypting using the receiver's private key RSA. So the private key will be there, and from there it will generate the key, random key, and from there it will generate the random key to decrypt the data. And if the key is right, then it can decrypt the data. If the key is not right, then it will not able to decrypt the data. And if the key is right, then it will decrypt the data and the data will be there. The data will be available here. Then we have disk encryptions. Now disk encryption is used to encrypt the whole disk, a block of data. It is used to do the confidentiality, encryption and protection. Confidentiality, that means disk encryption protects the confidentiality of the data stored on the disk by converting it into an unreadable code using disk encryption software or hardware. It provides the privacy, passwords, and hidden volumes. Then encryption, then disk encryption works in a similar way as text message encryption and protects the data even when the OS not active. That means if the operating system is not running, even that time also the encryption will be there. And if you try to add that hard disk into our disk into another machine, it will still show you as a encrypted. It do volume encryption here. Then the protection, with the use of the encryption program for your disk, you can safeguard any information to burn onto the disk and keep it from falling into the wrong hands. So either it is your Blu-ray, DVD, or backup disks. For doing this disk encryption, we have these different tools like Symantec Drive Encryption and GiliSoft Full Disk Encryption. This do what the Symantec Drive Encryption provides the full disk encryption for all data like user files, swap files, system files, hidden files on desktops, laptops, and removable medias, and it protects the data from unauthorized access. Then we have the GiliSoft full disk encryption. It offers the encryption of all disk partitions, including the system partition. It provides automatic security for all information on the endpoint hard drives, including user data, operating system files, and temporary and erase files. Then we have these other tools for doing the disk encryption. And nowadays in Windows, we have the disk encryption tool which is called BitLocker. And it can do encrypt the whole drive, the whole partition, whole drive, whole volume as a volume encryption. And it remains encrypted even the OS is not running. So even if you remove the disk from the machine and attach it to the other machine, it will still not be decrypted. It will still be the encrypted.